Hey there guys, welcome to my second set of AS level maths past paper exam questions on gradient of a curve using differentiation. So here we are going through two huge questions, a 7 marker and a 5 marker. Let's do it. Okay then, first up, the 7 marker. So Chris claims that for any given value of x, the gradient of the curve y equals 2x cubed add 6x squared minus 12x add 3 is always greater than the gradient of the curve y equals 1 add 60x minus 6x squared. We want to show that Chris is wrong by finding all the values of x for which his claim is not true. Okay, so first up, to make the job easier, I'm going to define the two functions. So I'm going to say let f of x be 2x cubed add 6x squared minus 12x add 3 and g of x is 1 add 60x minus 6x squared. Now, the question is about gradients of curves, so we need to get, for each function, we need to get the gradient function. We do that by differentiating. So, df by dx is gonna be 6x squared add 12x minus 12 and the g by the x, that's going to be 60 minus 12x. Now, Chris is claiming that the gradient of f of x is always greater than the gradient of g of x. In terms of the derivatives, he is saying df by dx is greater than the g by dx. So we want df by dx to be less than the g by dx. So then, we want 6x squared and 12x minus 12 to be less than 60 minus 12x. So, 6x squared add 12x minus 12, we want less than 60 minus 12x. So this is now a quadratic inequality which we need to solve. So let's get everything over onto the left. So we're going to have 6 x squared. Now we're adding 12x to both sides, so we then have plus 24x. And then we are subtracting 60, so we get minus 72. So that is less than 0. Now this has a common factor of 6, so let's divide through by that. So we get x squared, add 4x, minus 12 is less than 0. Okay, now to solve a quadratic inequality, really we need the graph. So here we are interested in the part of the graph below the x-axis. So to get the graph we need the roots of the equation. So the left hand side equal to 0. So x squared, add 4x minus 12 being equal to 0 factorizes to, well, we want a plus 4 in the middle, but a minus 12 at the end. So that's going to be x plus 6 times x minus 2. Now that then gives us critical values of x equals minus 6 and x equals 2. So those are the x-intercepts. Now if we sketch the graph, we now know it's going to look something like that, where this is minus 6 and this is 2. Now, we are interested in the region below the x-axis. So, our answer is x is greater than minus 6 but less than 2. Okay then, now for number 2. So this one involves exponentials and logarithms too. So the equation of a curve is y equals e to the 2x. Find the coordinates of the point on the curve where the gradient is 1/2. Give your answers in an exact form. So that means either in terms of logs or fractions. So, first up, we're talking about gradient. So, we need to find dy by dx. Now, to differentiate exponentials, we differentiate the power. So the derivative of 2x is 2. And then that just multiplies the original function. So we get 2e to the 2x. Now we want the gradient to be 1/2. So that means we want 2e to the 2x to be 1/2. Okay, so now we need to solve this for x. So let's divide through by 2. So e to the 2x is 1/4. Now to cancel the exponential, we take the natural log, so ln log of both sides. So that's going to leave us with 2x is log 1/4. Now, we can think of a log 1/4 as a log of 4 to the minus 1. Now, by the rules of logs, the power comes down the front, so we have minus log 4. Okay, now we're going to divide through by 2, so we get x is minus 1/2 log 4. Now we can tidy that up a bit by now using the power rule in the opposite way. So we could say this is minus a log of 4 to the half, which is then minus a log 2, because the power of a half square roots. Okay, so that's the x coordinate minus a log 2. Now to find the y coordinate, we sub that into the original equation. So y is e. Now it was e to the 2x, so it's now e to the minus 2 log 2. Now, if we sharpen up the log, we can have that as e to the minus a log of 2 squared, so e to the minus a log 4. Now we can also let the minus 1 into the log, so this is e to the log 4 to the minus 1, so that's a log of 1/4. Now, exponentials and logs cancel out, so this is actually just 1/4. So the coordinates are minus log 2 1/4. Okay then guys, that's it for now for gradient of a curve. The next set is gonna be stationary points. Hope to see you there. Take it easy. Take care.